All right, so you had some new ratios, which were the reciprocal ratios, which was cosecant, secant, and cotangent. In order to do it. It sounds like somebody has music or radio on or something. All right, so questions you might have come across for me on Trig A, my friends. What can I go over? It was just the odds unless you had time to hit the evens. So I can go over any of those.
Can you do 13?
Yep. All right. Number 13, we have obviously the right triangle, where we have A, we have B, we know this is 8 root 2, and this is 30 degrees. Okay, so the relationship you have to know is, oops, come on. Relationship you have to know is the side, the hypotenuse, which is 8 root 2, is always the square root of 3 times bigger. So if I go backwards, if I go this way, I'm going to divide by root 3. So this becomes 8 root 2 over root 3. Multiply top bottom by root 3. So that gives you 8 root 6 on top over root 3 times root 3, which is root 9, which is 3. So the side opposite of the 30 is this. And then that means that this side here, it has to be the, oh, I messed that one up already. My goodness, can't take me anywhere. Sorry about this. So the hypotenuse and the side opposite of the 30 is always half of it. So I have to divide by 2. So that's going to give me 4 root 2. Okay, so that's half of it. And then if I go this way, I have to multiply by root 3. So I get 4 root 2 times root 3. So that would give me 4 root 6. So my side lengths, the given are 8 root 2 is the hypotenuse, opposite of the 30, 4 root 2 because it has to be half of the hypotenuse, and opposite of the 60, because this was the 60 up here, has to be the square root of 3 times bigger than the side opposite of the 30. What else did you see, my friends? Doing all right? Sure? Going once? Going twice? Okay, so I take it you all did that. I'll go ahead and put it in the grade book for you. If you're showing me anything old, just show me next time we have class. A reminder that cohort B, so my Wednesday, Friday group, we will be meeting on the second floor. And I have, if you forget where it's at, just look at my door and it will tell you what room I'm in. Okay, cool. Now we got everyone here. Perfect. So are you sure there's no other questions on 8A, the homework? We're good. Excuse me. Okay, so I gave you the notes for 8B, yes? You have the notes they're blank?
Yeah.
Great. Thank goodness I didn't lose my mind too much. Let's go back and beginning of mine. All right, so we're going to start talking about the unit circle. The unit circle is a circle that is excuse me, that is located on the XY axis with its center at 0, 0, and has a radius of 1. Okay, the unit circle, we can embed any of our special right triangles into it, which you see you have your 30, 60, 90 and your 45, 45, 90. They can go into any of the quadrants. And let's just start building from there, see how we do. And I can plug that upstairs. All right, so these are the notes that I've given you. All right, so coordinate plane. So you should know that this is the x-axis, and you should know this is the y-axis. The very center is called the origin, which is the point 0, 0. And then you have quadrants, and we label the quadrants counterclockwise. And the method to the madness of this going counterclockwise, and this is the honest to goodness truth. I don't know any of you who are left-handed, but perhaps some of you are, I don't know. Descartes, D-E-S-C-A-R-T-E-S, it looks like Descartes, the mathematician that developed this, he was left-handed. That's why it's numbers that way. That's the math behind it. There's no other method of the madness why it labels that way. But things to know are you have an x and y value, so they're both positive over here. You have a negative x value and a positive y over here. Both x and y are negative in quadrant 3. And in quadrant 4, you have a positive x and a negative y. So that's kind of the foundation. If anything falls on the x-axis, obviously you have a 0 in the y position as a point. If anything falls on the y-axis, you have a 0 wherever it falls on the x-axis, or in the x part of the point. Okay, so let's move on. All right, so we want to find the measure of all 3 arcs. Okay, so if this is 115, that 90, this means it's 90 degrees. But we know that if I add up all the angles of a circle, it'd be 360 degrees. So you're going to go 360, and maybe I'll go 90 plus 115 to the side. So I get 5, 0. Okay, the 1, I get 205. So when I subtract 205 from this, that gives me 5, 5, 5, and this would be down here 155 degrees. Okay, so you have to know that a circle is 360 degrees. In order to do this, you have to know that the little square that we put in the corner represents 90 degrees. Seem okay so far? All right, so this is a thing you could go to and play around with. I'm not going to go to it because obviously we're here online. Circle with radius 1, centered at the origin. This is going to talk about the unit circle. This includes 16 angles around the circle, the 4 quadrantal angles, and the 3 angles in each quadrant. Okay, and like, what does that all mean? Okay, so first thing, I'm going to label it as 1, 2, 3, and 4. And again, this goes counterclockwise because Descartes, the mathematician that created this, was left-handed. So as we go around the circle, we're going to deal with all of these in degrees. Okay, we're going to deal with radians later. Oops, I didn't mean for that to happen. All right, so starting here, this is 0 degrees, and then this is 30 degrees, and then this is 45 degrees, and then this is 60 degrees, this is 90 degrees, and then sometimes you can't remember everything that took place. So think about this distance. That's 30 degrees. So if I go 30 degrees this way, it takes me 120 degrees. This takes me to 135 degrees. This takes me to 150 degrees. And then this takes me down to 180 degrees. Then we get down to quadrant 3. That's 30 degrees more. So that's 210 degrees, 225 degrees, 240 degrees, 270 degrees, 300 degrees, 315 degrees, and then 330 degrees. And then it takes us right back here, back up to 360 degrees, and it starts over again. So 0 and 360 lie on the same location. Okay. As I go counterclockwise, my angle is positive. Okay, if I go counterclockwise, or if I go clockwise, my angle is negative. Okay, so if you go around to the left counterclockwise, the opposite direction of a clock, it would be positive angle. As you go clockwise with the clock, or the second hand on the clock as it goes around, it would be a negative angle. Okay. So this is one of those we're going to keep referring back to it. The 30, the 45, and the 60, those all take place when we deal with something called a reference angle. It's coming off of the origin, or it comes off the x-axis. So when we have a reference angle, it's how many degrees above or below 0 degrees or 180 degrees are we? Okay. All right, so this is talking about what I just said. Angles who share the same initial side and terminal side, those are called coterminal angles. To find the coterminal angles, basically what you do is we show this 45 degrees right away. That makes sense. But then you have negative 375. So the red, notice the red is going around this way. We're counting clockwise. So it's negative in the direction. Negative 375 degrees actually doesn't fall exactly there. So think about this. Let me change that negative 375. That negative 375, if I did this off to the side, I'm going to add 360 degrees to it. So that's going to give me 15 degrees. So the 375 should have been down here as 15 degrees as the reference, not this one. Okay. And then 405, we go all the way around the circle once. So that's 360 degrees. If I go 405 minus 360, we're going to get 45 degrees. So 45 degrees exists with that. So I guess the 375 they had, negative 375 they had in the wrong spot, but it happens. Okay, we'll do a little bit more of that. So list 3 different coterminal angles for each angle given. So 30 degrees, think about 30 degrees, it looks like this. Okay, I could add 360 to it, so 390 degrees would also exist. If I added 720 to it, 720 goes twice around the circle, 720 plus 30 is going to give me 750 degrees. So 30, 390, 750 are all the same reference angle. The coterminal angle is 30 degrees because you're coming 30 degrees off of the x-axis. If I go to 135 degrees, it comes all the way over to here. So what you want to think about is this would have been a 45-degree angle to take it down. So you'd be referring to the 45, 45, 90 triangle if I said 135 degrees, but it happens to happen in quadrant 2. Okay, so if I wanted to get other angles on that, I would add 360 to that. So I'd go 135 plus 360. So that's going to give me 495 is the same. If I added 135 and 720 together, so it looks like 855. If I had 10 degrees, 10 degrees is like here. So if I added 360 to it, I would get 370 degrees. If I added 720 to it, I'd get 730 degrees. But notice I keep going positive on those, agreed? So then we talk about 180. 180 is over here. Okay, so 180 is fine. If I add 360 to it, I get to 540. Now I want to talk to you about something. If I go 180 minus 360, I get negative 180. That just means I went around this way. I came negative. This would be a negative angle for it. 50 degrees. Again, let's start doing some negatives. So if I add 360, I'm going to go 360 plus 50, which is going to give me 410 degrees. Well, let's go 50 minus 360. So that's going to give me negative 310 degrees. That would mean I would be going this way. Okay. Then 200 degrees, I could add 360 to it. So I get 560. I could subtract 360 from it. So I get negative 260. Negative 160, excuse me. Again, the negative refers to that I'm going clockwise. The positive means I'm going counterclockwise. Am I going too fast or any questions so far? And I'll let you catch your breath. I just got to verify what time we're done with class. So I just don't remember. All right, we go till 54. So 27 minutes. All right, moving on. Find the smallest positive. So this one, we're looking for a positive angle. So 370 degrees goes all the way around the circle once. So if I subtract 360 from it, I get 10 degrees. Okay, 370 and 10 degrees fall in the same location on the unit circle. Negative 135. So think about what negative 135 is doing. It's coming like to this. Okay, so that is negative 135. So where would I have to get to go from here to here in that direction? So think about what I'm going to do. I'm going to go 360 minus 135. That gives me 5. That's 5, 2, 225 degrees. So 225 degrees is the same location, but the positive location as negative 135. 750, that goes around the circle twice around, thanks to Tony Hawk and our snowboard and skateboard crews. We know 720 is 2 times all the way around. You don't go 2 times all the way around, you're not doing well. So I'm going to subtract 720 from this, and that's going to give me 30 degrees. So 30 degrees falls in the same location on the unit circle that 750 degrees would fall. 400, I'm going to subtract 360 from it, and that's going to give me 40 degrees. So 40 degrees and 400 degrees fall in the same location. Think about where negative 30 falls. Negative 30 is down here. So that's going to be 360 minus 30. And that's going to give me 330 degrees. That's the positive angle, meaning it went counterclockwise around. And then negative 270. Let's bring up a better color, negative 270. So negative 90, negative 180, negative 270. Well, how far is this distance here? That's 90 degrees. So 90 degrees falls in the same location on the great circle or the unit circle that negative 270 degrees would fall at. Going too quickly, or am I okay? Any questions? Okay, I'm gonna move on. Okay, a positive acute angle that is made from the terminal side of an angle to the x-axis. So again, remember I talked it's coming off the x-axis. The x-axis goes right through. The x-axis has 0 and 180 degrees on it. So we want to find the reference angle. Okay, the reference angle refers to what 30, 60, 90, or 45, 45, 90 triangle that we're going to deal with, or if it falls exactly on the X or Y axis. Okay, so we're coming off, what we're going to do with this is we are coming off how far up, how far up, how far down, and how far down. Okay, that's what we're talking about. We're talking about all these angles here that we could figure out how far I would rotate. Okay, and it comes off the x-axis. These are always positive angles, my friends. It's just what's the distance to, okay, as an angle. So I'm going to scroll down a little bit. All right, so the reference angle for 170 degrees. So think about where 170 degrees would fall. 170 degrees comes all the way to here. How much further do I have to go to get to 180? It's 10 degrees. Okay. 315 degrees. We'll do this one in purple. 315. So 90, 180, 270, right to there. So that is 45 degrees. So the distance here is going to be 45 degrees is the reference triangle I would go to. I don't have a reference triangle for 10 degrees yet, but that's okay. 190 is going to go the same type of way. So 190, we'll do in green. 190, I go here to here, that's 180, and then I come a little bit more. So that becomes 10 degrees. 240 degrees, 90, 180, 240 is down here. 240 is how far away from here, how far is this angle? That's going to be 60 degrees. So you refer to the 30, 60, 90 triangle there. 60 degrees is its own reference, okay, because it's less than 90 degrees. And then 150 degrees comes around to here. So I'd have to go 30 more degrees. So we're talking about a 30-degree reference angle. And the main things we have to start considering is in quadrant 1, our x and y values are both positive. In quadrant 2, we have a negative x and a positive y as far as a point goes. In quadrant 3, both the x and y as a point are negative, and in quadrant 4, our x is positive and our y is negative. Okay? All right, so I know I have some time, so let's talk about the main thing that we want to start considering here is we have this triangle. This is the same triangle, it's just I have the 60 degree down below. And then we have this triangle. Okay? So those, we have to understand the relationship about these. And when we do this, we know this is x, this is 2x, this is x square root 3. This is x, this is 2x, this is x square root 3. If this is x, then this is x square root 2. And that's kind of coming from your geometry class. Well, let me just give you some bonus footage of where this is coming from. I'm going to draw myself a circle first. I'm going to draw this circle. And then what I'm going to do from there is I'm going to start changing colors. So my friends, this triangle here, this is a 30-degree angle right here, right here, right here, and right here. Okay? Then if I change that and I say, well, I want the 60-degree angle now, the 60-degree angle is like up here. And I'm not exact, I'm doing the best I can with flying without a net. So this green, this angle here is a 60-degree angle coming off of my x-axis. So we're kind of inscribing these in there. And then the last triangle I can draw is pretty pink. This would be a 45-degree angle. And so all I'm doing is I'm inscribing those two special triangles, where one of the special triangles I use twice, where I use the 30-degree acute angle and also the 60-degree acute angle. I'm drawing those in. And what this is going to head towards is, because this has a radius of 1, these major points would go like this. But then I can find exact values for each of these points where I know these will both be positive. These points here, I'll have a negative and a positive. These three down here, we'd get both negative. And then these three over here, we would have a positive and a negative as far as the values go. And we're going to start getting to a point where we're going to say, what can I do to know these? And the nice thing is it goes with a really nice pattern, but that'll actually be coming up in our next, I think it's our next lesson, which is in class, which is fortunate. Then you get to see me and I get to see your reaction on your face going, what? Actually, C, as we're just converting, we're dealing with things in radians, which is just like the difference between degrees and radians is like in math, is like in chemistry. What's the difference between Fahrenheit and Celsius? It's just a different way of measuring. And then let's see, Thursday or Friday, we're going to be using the unit circle. Okay, yeah, we'll start building the unit circle while we're in class. And then E, cool, yeah, cool. So this is going, so we have some time. What kind of questions do you have for me on any of these that we could go over? We good? Or are you just being silent on me? Everyone content? Okay, so tomorrow or Wednesday, depending upon which cohort you're in, we will go over homework. So we'll go over the Trig B, and I'll assign that in a sec. It's actually just Trig B, and if we just do the odds, we should be fine. We'll go over the homework. I will teach Trig B, which should go pretty smoothly. It's just dealing with, we're going to have the radian amount versus the degree amount. It's nothing to worry about. And then the last 20 minutes or so of class, I will allow you to take back your test. Even if you turned it in, like if you've already felt you're good, I'll give you the last 20 minutes to take a good, honest look at it. If you still need more time, let me know tomorrow, and then we can take care of it. So, and that was a one-time offer going for you guys. I just wanted to make sure you had nice scores going in. If we share an off period, let's see, because we have this third, so I don't know how many of you would have first or second off, but I have second off. If you have second off, come see me. If you have, if you get here before school, come to my office if you want to go over stuff individually, and I'm happy to help you. And then this week I'm kind of busy midway through 8th period on Wednesday, Thursday, Friday with basketball stuff. So that's what we'll be taking care of. So questions for me, my friends? Okay, I'll get to the assignment. So your assignment will be Trig B. And we'll do the odds. If it is taking you longer than 20 minutes, just give me an honest 20 minutes. If it takes you less than 20 minutes, fantastic. But just take a look at it, and it should be something to go with. And then also, I'm going to share again. I'm going to go to this one. So in our class, let's just take a look where we're at. We are now finally down into week 6, so we're moving along nicely. In week 6, I have Trig B. That's the homework assignment. Just do the odds. I'll change that because you're my only class, so I haven't changed it yet. And then we'll take care of C and D this week as well. I think for the after Thursday class or after Friday class, I'm going to have a small quiz on Schoology that you'll have to do. You have a longer weekend, but I think I'll make it about 10 questions. Of course, if you're at home, you get to utilize whatever resources you have available to do well for you. So, my friends, that's all I have for you. Any questions for me for today? We good to go? All right, I'll talk to you all real soon. Have a